I'm ready to go. Are you ready to go?
Sure am.
All right. Well, welcome everyone. I'm Dana Cowley with Contractor Hanford Mission Integration Solutions. I'm joined with Jen Colborn, Cerise Peck, and Colleen Drinkard, and we're excited to be with you tonight. Tonight's meeting is a virtual public meeting and it is being recorded. Our event is about the new decontamination procedures for both the liquid effluent retention facility basins and the effluent treatment facility tank systems. This is part of a 60-day public comment period, which began October 26th and ends December 27th. We have a few technical details to discuss before we begin. We'll be using the chat box feature in Microsoft Teams. Click on the icon that looks like a thought bubble, and you can find it right next to the hand icon. In the chat, we've added the link to the Hanford.gov events calendar, and that contains tonight's meeting materials, how to submit your comments, and the evaluation link for tonight's meeting. If you're joining us by phone only, you can find all this on Hanford.gov. Now, if you've just called in, press *6 to unmute, and then return to mute by pressing *6. And we ask that everyone remain on mute during the entire meeting unless you're asking a question. If you need to step away, please don't put the call on hold, whatever you do. Just hang up. You can always call back in later. You can submit your questions in the chat anytime. Just indicate if you'd like us to read it for you or if you'd prefer to ask it aloud yourself. If you have multiple questions, please save them until everyone has had the opportunity to ask their initial question. And now let's turn the time right over to DOE's Richard Valle.
Thank you for that. Just waiting for the slides to come up.
Almost there, Richard. 1 second.
I'll turn my camera off now, Richard, so you can proceed.
All right, can you see it, Richard?
I see it.
All right, we'll go on mute over here. Thank you.
Okay. Well, good afternoon, all. As was stated, my name is Richard Valle. I'm a program manager here for the Department of Energy, in particular in the Tank Farm Programs Division. And like we've mentioned already as well, we're here to discuss the proposed permit modification in support of the Liquid Effluent Retention Facility, or LERF, and the 200 Area Effluent Treatment Facility, or ETF, decontamination process. And before we jump to the next slide, I just want to note that I do recognize this is a little bit of a more conceptual discussion here. So point being, I do not mind going back and revisiting any slide, reiterating any notion or just answering a question where it's needed. So with that, we can go ahead and jump to the next slide. Okay, before we jump into some of the specifics for the topic of the discussion tonight, we did want to highlight one of the main priorities ongoing here at the Hanford site, and that is our direct feed low activity waste, or DFLAW configuration. And as you can see in the busy slide in front of you, this DFLAW configuration integrates a number of individual projects, facilities, and infrastructure upgrades from the involvement of all Hanford site contractors. And it's through this DFLAW configuration that Department of Energy will retrieve, treat, and immobilize low activity waste. So if we just focus on the graphic for a moment, we see the AP tank farm kind of called out in orange, kind of in the center there. That is where we will stage tank waste for pre-treatment using the tank side cesium removal system, which is off to the left in that bluish bubble. So that tank farm, that tank side cesium removal system, or TSCR, will pre-treat the waste. We see the orange line indicating the flow. That pre-treated waste will be sent to the WTP, the waste treatment plant's low activity waste facility, called out in that teal color down below. And that's where we'll actually be having the glass making process with the pre-treated waste. The glass itself will be disposed of at the integrated disposal facility up in purple, top left. But we can see as a part of making glass, or the glass making process, there's that white line leaving the LAW facility going to the effluent management facility, which will help reduce the volume of secondary liquids that are created during the glassmaking process. And it's after that step that we see the white line continue to the unit group we'll be talking to today, the LERF and 200 area ETF in the top right orange. So we can see how the facility plays into the DFLAW program or configuration. So next slide, please. So this kind of puts some of that verbal discussion on the previous slide in text form. So we recognize that there's chemical and radioactive waste stored in Hanford's tank farms. We see the graphic showing a typical tank with its liquid and solid fraction, liquid in blue, solid in yellow. And again, it's through the DFLAW program that DOE will efficiently and effectively vitrify waste, immobilizing it in glass. We talked to the generation of secondary liquid waste from the glassmaking process, and then ultimately the LERF and 200 area ETF being used to manage and treat the secondary liquid waste. And it's, again, important to note here that during DFLAW, DOE will be treating the liquid fraction of that tank waste. I think we said it prior, but just reiterating again. So next slide, please. Okay, some more background, and here we talk to the regulatory framework. So at the Hanford site here, we are governed by the Resource Conservation and Recovery Act, or RCRA, federal regulation, and then that's flowed down in a dangerous waste permit for the Hanford site. The second bullet there notes that the Washington State Department of Ecology is the regulator, and we're currently operating under revision 8C of that permit. And then we, DOE, and in this particular instance, our contractor being Washington River Protection Solutions, are the permittees, and we're going to discuss a proposed Class 2 permit modification to this particular unit group, the LERF and 200 area ETF. Next slide, please. So here we give you some visual context of where that unit group that we'll be discussing in detail is located. So we have Washington State and the call out for the Hanford site. Right in the middle of that graphic is the 200 East area, and up on the top corner you can see the general location of this unit group, the LERF and 200 area ETF. Next slide, please. And so we've drilled down to this particular unit group where it's generally located. This is an aerial view of what they look like. So these facilities together work to store, treat, and dispose of large volumes of liquid waste, and as we've mentioned, will include the waste generated from the waste treatment plant upon startup of DFLAW operations. So the liquid effluent retention facility, or LERF, you can see up on the top of the aerial view there, comprised of a series of basins, and then we have the effluent treatment facility down below that will treat the waste. Next slide, please. All right, so we can start talking some of the specifics of this proposed modification. So it's important to recognize, here's where we give some environmental regulatory background, but as part of RCRA, which we discussed applies to us, RCRA requires that waste be identified by applicable waste code. So having that notion, we then further the background to state that we ensure effective and efficient treatment of liquid waste at ETF by ideally treating waste streams for waste codes that are similar in waste codes and chemical properties that are uniquely applicable. So RCRA requires us to identify the listed waste. As part of our operations, it's most effective and efficient to treat similar waste codes that have similar chemical properties. That's the intent of the first bullet there. Then we recognize for the second bullet that, again, in accordance with RCRA, once our hazardous waste and its applicable waste codes have been identified, that listed waste code will apply to all future liquid waste that is stored in the particular system, so a tank system or surface impoundment. Tank systems being specific to the 200 area ETF, and surface impoundments, like we said, are basins that comprise the LERF. So we've developed procedures to remove waste codes from tank systems and surface impoundments. And that's what will be the purpose of the discussion going forward. Next slide, please. So we touched on listed waste codes in the previous slide. This gives you a general understanding of what that means. So a waste is determined to be hazardous if it is specifically listed in one of the 4 lists, F, K, P, or U, found in federal regulations. And you can see the citation there. So for example, in the F list, that corresponds to non-specific sources from certain industrial or manufacturing processes, and it determines those as being hazardous. And so, for example, spent solvent waste would be identified as F01 through F05 waste codes. Similarly, for multi-source leachates, you'll see that referred to as FO39. And then the same notion applies for the P and U lists. So those are particular to waste being discarded or intended to be discarded, or commercial chemical products, and it determines those as being hazardous. And again, an example provided there being tetrachloroethylene as a U210 listed waste. So these particular examples are specific to our proposed permit modification, which is why they're called out here. And for all of them, we'll discuss in subsequent slides. Next slide, please. Okay, so we talked about the fact that we have developed decontaminate procedures, but why would we want to do that? So this slide tries to convey that. The first bullet there is trying to recognize some of the background. So we store waste in the LERF basins. Again, the LERF is comprised of basins or surface impoundments, and those are typically segregated so that we can optimize future processing at the effluent treatment facility, the 200 Area ETF. So the segregation also helps isolate waste codes from the various waste streams that we receive at each LERF basin. So now with that understanding, if we were not to segregate them, the second bullet shows that non-segregation could result in a particular LERF basin and its contents carrying multiple waste codes. So even after we remove the non-segregated waste codes, we would still need a decontamination procedure to potentially remove waste codes that are no longer applicable to that basin. And I know that was a little wordy, so the next slide is an example to try to put that into context. So next slide, please. So here's this hypothetical example for LERF. Again, we've seen this graphic, LERF being at the top there, comprised of the basins. So for this particular hypothetical example, if we assume that we want to remove the cover from LERF Basin 44 so that we can replace it, we would have to transfer the contents from 44 into 42. So when we do that, let's recognize what we have in the basin. So the first item there in the call out at LERF Basin 44, we see that is FO39 listed waste. So we're going to be transferring that following the arrow, our first transfer into LERF Basin 42. First call out in the LERF Basin 42 bubble shows that is FO1 through 5 listed waste. So after our first transfer, we now have removed the contents from 44, but the basin is still FO39 listed waste. And then we see in LERF Basin 42, after the first transfer, we have F1 through 5, as well as FO39. So that's where we stand after the first transfer. Now, if we assume the cover replacement is complete, we want to reintroduce waste back into LERF Basin 44. So we'll transfer out from 42 into Basin 44. And that's what's shown there as the second transfer, the arrow going back into 44. So after the second transfer, we'll see that now we have F1 through 5 and FO39 at Basin 44. And similarly, we have those same waste codes at Basin 42. So if we wanted to remove the FO39 waste code, which is highlighted to you in that call out, we would be performing the Decon procedure that that we've developed, and then after the decontamination, you can see the FO39 code is removed from LERF Basin 42 in this example. Okay, next slide, please. So similarly, why would we want to decontaminate at ETF? So again, providing some context and background for the first bullet there. ETF generally processes waste from a particular LERF basin in what we call a campaign. And each campaign is again, typically limited to the contents of a single basin. And we develop a specific processing strategy for that campaign. So performing campaigns from different basins could result in the 200 area ETF tank system carrying multiple waste codes. After a campaign is completed, an ETF tank system decontamination procedure would be needed to remove waste codes for the subsequent campaign that no longer apply. And again, we'll try to do something similar on the next slide to try to convey this with an example. So next slide, please. So here we have the hypothetical example from for the 200 area ETF. And for this example, we assume that we're going to be processing and drawing feed from LERF Basin 43 first. You can see that, the call out there, first transfer. So when we do that, we recognize that LERF Basin 43 has the F1 through 5 waste code as well as the U210. So assuming we've completed our processing from 43, we look to see what our next transfer would be, like we said, Basin 42, and we recognize that that one has only F1 through 5. So we would want to decontaminate for the U210 waste code prior to beginning the second transfer. And you can see after decontamination, the U210 code goes away, allows us to step into the transfer number 2 there, the campaign number 2 at LERF Basin 42. And again, only the F1 through 5 waste codes apply. Next slide, please. So we've talked about the development of these decontamination procedures. It's important to recognize that we did draw on regulations that are currently out there and try to draw upon those principles. So federal and state regulations describe procedures that allow for the reuse of empty containers, and in specific circumstances, you can remove the waste codes for those empty containers. Now, a container has a regulatory definition here, and we can see it listed there. It's any portable device in which a material is stored, transported, treated, disposed of, or otherwise handled. So there's a procedure out there for containers to be able to be reused and remove the listed waste code in specific circumstances. However, the LERF is not a container. It's comprised of surface impoundments or basins. And similarly, the ETF is not a container. It's comprised of operating tank systems and ancillary equipment. So we drew on the principles of the existing regulations for our proposed decontamination procedure. Next slide, please. So the decontamination procedure, we've touched on how it's used. In this slide, we show that the proposed permit modification would implement a similar approach here at the LERF and 200 area ETF. So in our permit modification, there's a specific table, table B3, that identifies listed waste constituents. So for each of the listed waste codes, there's a waste constituent. And for each of those constituents, there's a performance standard that must be met. That's a numerical value that's cited, saying this is the standard we will need to decontaminate ourselves from a particular waste code. Subsequent in the modification there, the language, there's 2 sections, one for LERF and one for ETF, that steps through the actual steps and procedures towards determining whether a particular waste code has been decontaminated. And at a high level, that includes sampling, calculations of a flush volume, and then performing flushes. And there's particular caveats for LERF and ETF, I would encourage you to go to the actual permit section and read the steps for the specific details, but that provides a general highlight of the decontamination procedure. Next slide, please. And so for this permit modification, again, particular to the LERF and 200 area ETF, we've modified two addenda, Addendum B for the waste analysis plan and Addendum C for the process information. And again, would encourage you to refer to each of these addenda in the permit modification to see the particular language that was proposed or modified as a result of this modification. Next slide, please. And as we've mentioned previously, again, specific to the LERF and 200 area ETF, this is a Class 2 permit modification. There's a corresponding 60-day public comment period, and it's currently open and will run through the 27th of December. Please submit your comments either physically or electronically through the means noted below. And with that, I think the next slide will open it up for questions. So next slide, please.
Richard, thank you for doing such a good job with the presentation and explaining it to us. And I see Susan has just turned her camera on, and if you can hear me, Susan, I believe you were first in the queue. Please go ahead.
Thank you, and thank you for this presentation. I have absolute confidence that you know what you're doing, but much of this was so technical that when you talk about removing the waste code, does that mean you're removing waste or just removing a code by which you dispose waste? And is there any output from the LERF? You talk about transferring and decontaminating and all that, but eventually there's some stuff left. Is there a plan for disposal of that? And maybe there isn't something left, and I don't quite understand that. Thanks.
Okay. So I think you have two questions in there, and if it needs to be a back and forth, more than happy. Just want to make sure we answer your question. So the first one, I believe, was if we're removing physical waste or not. So I think I would probably call back to the fact that, you know, the LERF, it's not a container, but let's say we're using the word container here. It's a surface impoundment, but a container of sorts. Doesn't meet the regulatory definition of a container, but it holds waste. So if we introduce a waste code that long-term will not apply to that particular basin, that particular container that holds waste here at LERF, then we would want to remove that waste code so that it doesn't apply the same treatment standards later on down the road. So we're removing the waste code from the container, so to speak. Again, it would be surface impoundments at LERF or the tank systems at ETF. And then ultimately, the mission of both of these facilities is to process waste. So I think that might have been your second part of your question. So we will continue to stage waste at LERF and treat it at ETF. So I'm not sure if that answered your second question, but ultimately all waste at LERF will be, the intent is to be treated through ETF.
And then disposed of where?
So there's two outputs at ETF.
Okay.
Yeah, so at ETF, there's two outputs. There's the water that has been treated and will be verified for discharge to the ground.
Okay.
And that constitutes the large portion of the output at ETF. And then there's a secondary waste stream that's currently solidified and disposed of at the on-site landfill at Hanford, Erdif, the environmental restoration disposal facility.
Okay, and then both of those waste forms will be characterized so that there is just not an assumption that they're just going to go there, but they'll be characterized. That's part of the process, so that you know that they can be disposed there.
Correct.
Okay, great. The waste, removing the waste code is the confusing part and I worked at Hanford for 25 years, and I've been on the Hanford Advisory Board for a long time, and that term, I've just never heard that. So now it's starting to make a little more sense. Thank you.
Thank
No
you,
problem.
Susan. Richard, we appreciate that. And Colleen Drinkard is monitoring the chat. And Colleen, who is up next?
It looks like Liz Matson is up next, or Liz M. How does decontamination remove a waste code, and what does decontamination mean? So Liz, I'm not sure if that summarizes your question.
Yeah, I think, I mean, it follows up on Susan's question. I'm still lost with the waste code. Are we deleting, are we like changing a document? Are we getting into the basin itself and scrubbing it?
I think so. So again, we want to segregate waste so that we ensure that the right treatment standard is applied to a particular waste, and that's based on the waste codes that the waste have. So we talked about a few examples where we may have to either non-segregate the waste streams or at LERF, for example. And so we don't want a waste code to continue to apply to a basin when that waste is no longer being received at it. So we're left with a position of what do we do? The waste isn't there anymore, but the waste code remains in the basin. So we've developed this decontamination procedure, which involves sampling, flushing, and the calculations to determine the amount of flush volume needed so that we can, like we talked about in the particulars, make sure that we meet the performance standard and say we are decontaminated of a listed waste code. Did that help?
A little bit. So it sounds like when you say separate the waste streams. So if I'm just going to make it easier, not real codes. Say there's waste A and waste B mixed together. So you have an A-B basin and you want a just A and a just B basin. One question is, how do you actually separate A and B waste if it's mixed together? Wait, to non-segregate? Or are you or is it more taking A and B waste that is separated and moving them into the same basin?
So in that example, if we want to go back to just A and just B, we would recognize that, for example, in that A basin, B would no longer be being introduced into it, correct? It's just there in one instance, and it's not expected to be reintroduced back into the basin, which is why we want to make it just A again, right? So then we would, this is again particular to LERF, but we would pump down to the limits of LERF. There's a residual heel in LERF, so we'll pump down as much as we can, either by treating or transferring. So now that A basin is pumped down as far as it can go, we will take a sample to see, in your case, Liz, right, you said you want to get rid of B, right, in the A basin. So we would take a sample to see what the concentration of B was. And again, the procedure spells it out in great detail, but we would calculate a flush volume so that after we flush, the concentration of B is at or below 80% of that performance standard, that numerical value for the concentration. And if it's at or below 80% of that performance standard, we would say we're decontaminated of that waste code.
That helps. Thanks.
Okay.
Thank you, Liz and Richard. And let's go to the phone line for those who are joining us on the phone only. Is there anyone who would like to ask a question? Hit 6*. If no one would like to ask a question on the phone, then Colleen, who do we have next in queue in the chat, please?
Next question from chat is Maya Burke, and her question is, how does flushing work? Where will the flushing water be sent after decontaminating LERF or ETF? And does the flushing liquid need to be treated?
Yeah, thanks, Maya. So the flushing, how does flushing work? So it's good that the question was asked earlier. So as we stated before, I think in the first question, one of the outputs from treatment at ETF is treated waters that will be verified prior to discharge to the ground. So we would actually reuse that verification water, is what it's called, to perform the flushing. We would send that verification water back in maybe your example LERF, in the example prior LERF, so that we're not adding additional volume, right? If you draw a box around your system, we're still using water within the system, these verification waters. So where will the flushing water be sent after decontaminating to LERF? So I think maybe that'd be answered with the second part there. Does the flushing liquid need to be treated? So yes, all the volume at LERF ETF will eventually be treated, whether that's flush volume or waste volumes that's in the basin. Does that answer that?
Yes, thank you.
Okay.
Those are all the questions that I see in the chat. Let's check the phone lines one more time. If there's anyone who's just dialed in on the phone and would like to ask a question, hit *6 and we'd love to help you. All right, not hearing anyone else on the phone. I see there's a new question in the chat. Colleen, who do we have, please?
Well, the next new question is from Simone Answer. So the question is, so verified water is already treated water that then is used for flushing and then needs to be retreated? So that's the question.
That is correct.
Okay. And then there's a follow-up question from Liz. Does the verification water come from ETF?
It does. So it's one of the outputs of the ETF, treated waters that will be verified.
Would it be helpful if we went back to one of the other slide examples? Would that help the group?
We can certainly pull up the aerial view of ETF. Yep, that will help. I think there's a more zoomed in version up above. And okay, maybe not as zoomed, but still. So you can see those at the bottom of the aerial view there. There's 3 tanks, those cylindrical units there. Those are the verification tanks. So they're at the back end of the effluent treatment facility. As we're processing waste, those will be used to accumulate the treated waste that will be verified as treated and ultimately discharged to the ground if they are verified as being treated. Like we noted in a few of these questions, in certain circumstances where we need decontamination flush waters, we will be using the verification water.
All right, thank you, Richard. And Jen, thanks for pulling up the picture. It helps me to look at the pictures, see what's what. And Colleen, it looks like we have a few more follow-up questions in the chat.
Yep, the next follow-up is from Maya Burke. Do you test the heel after flushing to confirm it meets the decontamination performance standard?
I'd have to go back to the particulars for LERF in this instance. Sorry, Maya, if you want to put that question in an official comment, we'll get that answer to you.
right, thank you.
And then next from Susan Lefband, does anyone from ecology have anything to say about this change?
Hi, this is John Temple with Ecology. Are you guys able to hear me? Hi.
Yeah, we can.
Yeah. Yep. For this one, yeah, Ecology, we understand the flexibility really LERF ETF needs when DFLAW becomes operational. So specifically for this decontamination process, we've been working with DOE and WRPS for almost a year now to develop an acceptable approach for decontamination. And as part of this, we included our headquarters and part of the discussions, our compliance team, and EPA as well. So I feel like we did our research, our due diligence, and are comfortable with this approach and that it's protective of human health and the environment. So thank you.
Thank you. And so let's just double check. We haven't heard from anyone who's on the phone only, but I just want to make sure I'm not neglecting anyone. If anyone has just called in using the phone line only, press *6 to unmute, and please go ahead and ask your question. Okay, I'm not hearing any more. I see Susan has popped back on. And Susan, do you have a follow-up question?
I think that we did Susan, so I think we were on to Liz, and Liz had a couple, another question about where the waste streams come from, asking maybe to talk through that, and then a follow-up talking through all the waste streams come from LERF and when to run a campaign. So did you want to clarify that question, Liz?
Sure, if it's helpful. I think it would be, it seems like most of this public meeting is just wrapping our brains around how LERF and ETF work. Because there's waste streams, as I understand, coming from different places, but I think the timing is confusing. Is waste constantly coming into the LERF basins? Is it really infrequent? Is it once a year? Do you know, do you say we're going to use this basin for the waste from these 3 places and this basin from waste for these 3 places? Are you sampling it as it comes in to figure out what waste code applies and then putting it in a certain place that can only have certain waste codes? Just kind of talking through what it looks like how the waste is coming and being accepted.
Right, and I think you hit the nail on the head. So we have a waste acceptance process. Our generators provide a waste profile so that they understand the composition of their waste and what they'd be sending to LERF ETF. They would describe any listed waste codes that apply to their waste, and that would allow us operationally to just do exactly what you said, say that will then be destined for this basin. But I think it's probably worth noting, so for LERF in particular, I know we've been using that as an example. That is not a decontamination that we foresee happening with regular frequency. In our example in the slides, you see it was as a result of a cover replacement, which is a large task, a large endeavor that required us to non-segregate the waste. So for most of the time, like you're saying, Liz, we know what's coming our way, where it's going to be stored. If there's an operational need that requires us to non-segregate, it would be the only time that we would have to decontaminate a LERF basin. So maybe that provides a little bit of context.
Can you just talk about where the waste streams are, like kind of the timing? Like if we were watching a time-lapse video that had superimposed labels, would we be seeing tanker trucks bringing waste? I mean, I know there's pipelines, but I don't know if those are used, if those are just kind of set aside for the waste treatment plant, or if they're used routinely. Just kind of like, what does it look like? And where is the waste coming from? Like if you had like a pie chart, most of it's coming from here, and most, you know what I mean?
Right. So the LERF basins currently comprise of 3 basins. We've noted that we're in the process of installing a 4th basin. So then, just at a high level, our plan is to allocate 2 basins for the waste treatment plant when that comes online, 1 basin for the 242A evaporator and the process condensate we receive from there, and then a miscellaneous basin for leachates and such, and tanker truck shipments like you had mentioned. So that's at a high level. Again, we want to keep the, I think that question's relevant to this discussion, but we want to try to stay within the scope of this meeting being particular to the LERF decon, or I'm sorry, the decon procedure in general.
That was helpful. So I'm just trying to understand how often you're using it, because you talk about the campaigns. So I'm just trying to imagine, like you've talked about scenarios under which you'd need to decontaminate. It sounds like it could be a waste code switcheroo, or it could be replacing a cover. Is that something that happens once a year, once every 6 years? Like, how often are they filled up? Or if one fills up, does it sit for years? Is it, you're running a campaign every week? Like, what's the timing look like for this? And I do know once WTP is up and operating, the frequency will change, but like, how active is this?
Well, again, I'd go, well, maybe to answer your question. So we just finished replacing our last basin cover. And so the 3 existing basins now have new basin floating covers, and those that were replaced were original to the facility. So that was 20-year life for that floating cover. I believe our new ones have a similar or slightly higher design life. But so you can see that won't happen very frequently, the need to non-segregate waste due to a cover replacement. And then I'd go back to what you said earlier. We do have forecast planning of where waste is destined to go into LERF. So again, it would take an operational need, an emergency, so to speak, for us to non-segregate the waste. We know, like we said, we will be able to segregate the WTP from the 242A from the miscellaneous.
And sorry, just, and if there's other questions, I'm just still trying to understand how often you're using, like, when was the last time you ran a campaign through ETF? And when you run a campaign, do you empty an entire basin at once? I'm trying to understand how you're getting this, what's it called? The verification water. Like if I say basin 41, you empty it, it goes through ETF. You have that verification water on hand to do, like, you would know ahead of time you need to do the decontamination? Or is that, it sounds like the decontamination process is really rare.
For LERF, I would say that's a true statement. For ETF, it depends on what our sequence of campaigns are going to be. It could be very well be that we do a series of campaigns that all are only applicable to the F1 through 5 waste code, in which case we wouldn't need to decontaminate in that instance. But if we're going to switch to something like the miscellaneous leachate waste stream, we would need to decontaminate ETF prior. So it depends is the answer.
And so when you say, so just to make sure I understand, so you're doing your miscellaneous, do you know which basin that is? What number the miscellaneous one is going to be?
Oh, we'd like that to be 44.
Okay, just so, not holding you to that, just so it's easier to refer to. So if you're running 44 through ETF, do you need, like, how often is this happening that you're sending waste through ETF?
So I think, like we presented elsewhere, right now, ETF is in the process of substantial upgrades. So to allow for more time for upgrade work, we've seen a little bit less processing in the last couple of years, but normally in the last few years, we've processed between 1 to 4 million gallons through ETF a year. Again, the last few years have been a little lower to allow for project upgrades. But then that processing need will ramp up once the WTP DF law effluence starts to be received. So I think to answer your question, there should be no shortage of verification water, if that's what you're trying to ask there.
Yeah, just to get a sense of, like, when you're in full swing, all the basins are full, you're pretty much upgrading 24/7 or quite close to that? Or is that too frequent?
24/7 for a period of time, once we meet our campaign target. And that could be, like we said, 1 to 4 million gallons historically, or in the future, that'll increase to 4 to 8 million gallons annually.
Thanks, that was helpful to get a sense of this.
Mm-hmm.
Thank you, Liz, and thank you, Richard. And I see one more question in the chat from Maya, and if I was listening carefully, Richard, I think you answered Maya's question in your discussion with Liz, but if you can see it, it just says, Maya says, I'm just curious, how do you know that the waste code has been removed if you aren't sampling the heel after flushing the basins?
Yeah, Maya, I think that's a offshoot from your prior question. I want to verify that is written in there. I agree with your sentiment, but we do calculations to try to ensure that we know the flush volume. You know, we can analyze the flush volume needed to determine that that the performance standard has been met. So again, allow us to respond to that formal comment and get you the formal answer.
All right, thank you very much. One more check on the phone. Anyone who's on the phone, press *6 to unmute. And I'm not seeing anything else in the chat. Colleen?
Nothing else in the chat. Yeah, looks like Susan Lexband is thanking us for the answers. Thank you, Susan.
All right, and Liz, please go ahead.
Sorry, Q&A with Liz tonight. Can you talk a little bit about the heel? Like, when I hear heel, I think of something solid. Is it solid or sludgy? Are there solids in the water, or is it filtered out? You know, I imagine it's just like water, but
yeah, when we refer to heel, it's just the residual volume left in the basin after the extent of the permanently installed transfer pump can remove waste. So it's just a residual amount of water.
Okay.
Or water.
And do you ever find solids in the basins?
So our waste acceptance criteria requires that generators meet a filtering solids criteria. We would not expect to find solids unless it was some type of anomaly.
All right, I don't believe we have any other questions. Liz, were we able to answer your questions to your satisfaction?
Yeah, I think so. It sounds like the heel is just leftover water, leftover contaminated water. I know you have to call it certain things, but I think this is mostly for us to help translate how do LERF and ETF work. If we can understand it, then we can also translate it so the general public can understand it better. Especially the timing. I guess that is a question, is what's the time frame? And I understand waste treatment plant timelines are totally not reliable, but when are you expecting work to ramp up significantly?
And when you say work, you mean receipt of
Yeah.
additional volume?
Receipt of liquids. Yeah.
Yeah, it'd be, so there's a ramp up period to DF law, so it'd be during steady state operations of DF law.
All right, if we are not hearing or seeing any other questions, I want to thank everyone for their participation. If you go to hanford.gov, look on the events calendar in the bottom right-hand corner and click on tonight's meeting or this comment period, you'll find the presentation materials, all the details on how to submit your comment. We also have an evaluation form here in the chat. We'd appreciate if you fill it out and help us improve our meeting process. And on behalf of DOE, we want to thank everyone for joining us tonight. We appreciate you coming and making the effort to understand this complex world we call Hanford, and we wish you a wonderful evening.